All right, friends, it's T-Man, and I'm back with another, you could say, I guess, educational video. So, I've mentioned before on my channel, I posted it, and, there's this guy always trying to debunk me. He's got to debunk me, He's always writing in the comment section. Well, you're debunking what exactly? The information from NCBI PubMed, is that what you're debunking? Because you're not debunking me, because I just keep bringing up the information. So you see, you're debunking me. You're not debunking me. You're debunking NCBI, and you're not doing a very good job at it, but whatever. Anyways, man, we're going to talk about myonuclear domain, because I remember a while ago, we talked about this. They said, well, there's another part here. It says, is myonuclear domain sealing hypothesis dead? Like he goes, well, there's a way to get over it. There is always a way to go over it. I talked about it before. But yeah, okay. So yeah, it's is myonuclear domain sealing, is the hypothesis dead? Is it dead? Well, it's not dead, but I will explain something that you might not have known before, and it's maybe could be relevant to help you. You may want to know it. So yeah, I clipped out some stuff. I put it in the community section. All right, it's the same thing. I just clipped out these parts, okay? I'm not going to go through the whole thing, man. It would just take forever. I just think that these parts are probably more important, okay? So, it has to do with age-specific response to myonuclei, hypertrophic stimulus, okay, mock.etl, performed synergistic ablation in young and mature mice, and found that SC depletion prevented hypertrophy in the young mice but not in adult mice. That's very important. Listen to what they say. The discrepancy may be explained by the fact that the young mice in the maturation phase were dependent on SCs, these satellite cells, for growth and hypertrophy. So young mice, that would be young people too. Trust me, it's young people, man. Okay? It's the test, forget it, just because it's on mice. I know this for a fact through experience, okay? So, I wanted to talk about this a while ago. I should have brought it up a while ago, but okay. So this is one problem that young people have when they go to the gym lifting weights, and they can't figure out why older people, they see these older guys walking around and they're so much bigger, and they think, holy shit, man, they must be on steroids or something, But as a mature person, if you're really putting more effort into it as a mature person, you're going to get bigger. And the reason why, because like it says here, the discrepancy may be explained by the fact that young mice, okay, so hold on a second, I'll go back to this part. Performed synergistic ablation in young and mature and found that SC depletion prevented hypertrophy in the young mice, SC depletion, but not in adult mice. So when you don't have enough of them, and here's the thing, it has to do with maturity. So this discrepancy may be explained by the fact that the young mice in the maturation phase were dependent on satellite cells for growth and hypertrophy, whereas adult mice that have attained maximal growth use the reserve transcriptional capacity of their resident myonuclei to support hypertrophy. So, because some people will say, well, you could still, there's these reports, it says that the muscle will hypertrophy regardless of the nuclei. Yes, but they still need nuclei to hypertrophy. What they're saying here is transcriptional capacity of their resident nuclei, the ones that are already there, to support hypertrophy, will support hypertrophy, more hypertrophy. But to an extent, of course. You understand me? It won't go so much further. I'll bring up a map and show it to you. So these highlight the essential role of satellite cells in supporting hypertrophy in an age-specific manner. See that? Age-specific manner. That is the difference between older people and younger people. All right. So young rodents require SCs for muscle hypertrophy. As the resident MDS, or myonuclear domain size, hits a ceiling limit during initial hypertrophy before SC activation becomes mandatory to support further hypertrophy. However, Mature rodents have myonuclei with greater transcriptional reserves. So this is what they say. Mature rodents have myonuclei with greater transcriptional reserves. And the concept of myonuclear domain sealing and domain size rigidity is not strictly applied to them. Yeah, but you know, as you get bigger and bigger, you have to do so much more to get more of this damage to get the progenitor to donate its nuclei. It's a complicated process, bro. And you really have to eat a lot to push that domain. And sarcoplasmic hypertrophy is very important as well. They really go hand in hand. One can exceed the other, but definitely, yeah, it does, you need them both. Okay, but anyway. So, where was I? There is a role of fiber type as well, as myonuclei from type 2 fibers have greater transcriptional capacity than myonuclei from type 1 fibers. Fiber type transformation during mechanical overload can further complicate the notion of the MND sealing, as type 1 fibers may limited myonuclei transcription. Where was I? Hold on a second. Transcription reserves are converted to type 2 fibers during sustained mechanical overload. Yeah. Okay, so what do they say here in the next part? They say that hypertrophic stimulus is the prime. Hypertrophic stimulus is a prime determinant of activation of otherwise SCs and the amount of hypertrophy. During resistance exercise and high to moderate endurance exercises, myotrauma and micro injuries stimulate the release of cytokines in the immune system, which activates satellite cells. Thus, it seems that satellite cell activation in resistance exercise is at least partly due to the microinjuries and the resultant inflammatory response, which initiate the process of what? Regeneration. The repeating cycle of damage and repair, along with the activation of myogenic regulatory genes and increased plasma levels, when I say plasma levels, it would be, plasma levels, of anabolic hormones such as testosterone and IGF-1. So IGF-1, okay, that's why, you know, a good type of starch is really good to, I would say, no carbohydrates other than the starch and protein. That's it. Your natural diet, and you can eat some potatoes to add this starch. That helps to push that domain, okay? As a young person, I wouldn't do this when I'm older, man. I'm not eating any sugars now when I'm older. I'm not doing these things. My body, I can't handle it, man. The sugar stuff, it just, in an older body, forget it. But when you're young, you can kind of handle some of this stuff. I don't know. But you wouldn't want to be a runner and be pumped. You don't want to get pumped running. Trust me. That's why you want to be on a high-fat carnivore diet, high-fat animal diet, than being on carbohydrates and running. You're gonna get pumped, and that'll inhibit your running abilities. That'll fuck you up. That's for running people, man. I'm not joking. You have to get your body adapted to running on high fat, because you're so adapted to running on sugar, on drugs called sugar. You're on drugs, bro. If you're eating anything that has carbohydrate, a sugar in it, you're on drugs, man. I'm sorry, but that's just the truth. Okay, but whatever. So yeah, so this domain, whatever, MND size. Yeah, so micro injuries, that's what activates it. You get the picture. According to the nuclear domain theory, the donation of additional myonuclei by satellite cells occurs when myonuclear domain reaches a maximum threshold size. See that? It has to reach, I told you that before, it has to reach an MND size limit, a threshold limit. Once it reaches that limit and there's a micro injury, only then will it donate its nuclei to that domain to support further muscle growth. And what does that mean? Somebody asked me, hey man, does HMB, if I take HMB, a supplement, that's gonna somehow, it's gonna suppress something and cause muscles to grow magically, a magic pill? I'm telling you, there's no Jack and the Beanstalk and magic beans, bro. Ain't no magic beans gonna grow any muscles. You get it? They're supplements. They may help and aid in something, but they're those supplements, those amino acids, they're found in food. They're incorporated in food and meat and fish and whatever. So does it really matter? Okay, they have concentrated in high dosages, right? These amino acids. They do something in high dosages. They do stimulate something. You know what I mean? But the problem is this. When you stop taking it, it was induced artificially. It wasn't induced naturally. And so, bye-bye all that whatever. But anyways, yeah, you get the picture. So among the anabolic hormones triggering hypertrophy, increased levels of IGF-1, which is stimulated by mechanical overload, which is muscle damage, contribute to hypertrophy by inducing satellite cell proliferation and differentiation. They're talking about muscle damage. By increasing the expression of cell cycle progression. So look, when you max out that domain, this is how you max it out. You need to be in an anabolic growth state. That's how you max out the muscle cells. You max them out. When it reaches maximum threshold, the muscle cell, the MND size limit in a cell reaches a maximum threshold when you're in an anabolic growth state. Okay? In an anabolic growth state, it'll reach that MND size limit, and then it'll donate its nuclei if it was injured in that period of time. That's why I say I do a very sophisticated workout regime to get that. I try to explain this before. 5 times 10 or 5 times 12. All muscle groups, and I mean all muscle groups for a total upper body workout, and then the next day legs. But after your workout that day, let's say it was a Saturday, you did your whole upper body. You head down to a buffet. I don't know, you got a local buffet or something, because I don't think you're going to eat out like that at home, dude. And so you need to eat a lot in the morning, and then you head down to a local buffet after your workout. Time it. I don't know if you have time for that. I don't know if it's dinner or lunch, whatever. And go eat for whatever hours they're open. If it's 4 hours, eat for the entire 4 hours. Sit down and try to eat as much as you can for that 4 hours. But try not to eat too much of these, try not to eat too much of these fillers or weird stuff, plant foods and stuff, and sugary stuff and all that. You can eat some carbohydrate, potato. And I would stick to all kinds of different proteins, shrimps, mussels, whatever is there, seafood stuff, whatever. And beef and whatever else is there. I don't know, chicken, something. You figure it out, man. Roast beef, whatever. You eat the good stuff, okay? And you sit there and you take your time. You eat and then you drink water and you keep packing it down and packing it down, and then you leave. You get it? Yeah, and so that will suppress the catabolic hormone. It'll convert the catabolic hormone to an androgen, so it doesn't have to compete with the myocytic androgen receptor, making you anabolic. And now you've suppressed the breakdown. In other words, you've exceeded breakdown in protein synthesis. Protein synthesis needs to exceed that breakdown. It exceeds that breakdown when you're in anabolic growth state, like it says in science. It says, in order for muscles to grow, protein synthesis needs to exceed that breakdown. If it doesn't fucking exceed that fucking breakdown, then you're not gonna, like it says here, you're not gonna reach, MND is not gonna reach maximal threshold. And if it doesn't reach that maximal threshold, you can go and try to injure these muscles as much as you want. It won't work anymore. And the only way you can get any other growth, eke out any other growth, is through an adaptation process. In other words, you must do things that you're unfamiliar with, that you've never done before or unaccustomed to doing. In other words, if you've never done these other type of exercises before, you will get an adaptation there. But then it'll end. There will be no more growth. You understand me? But if you want a further growth, even in the exercises you're doing in the gym, you got to resensitize. You have to give your body a week to repair and remodel. So you need to do the whole upper body in one shot. It's got to be a 5 times 12, between a 65, 75 pound lift, whatever. You figure it out. Lift something heavy, but not heavy enough that you're killing yourself, that you can make it for 12 reps, okay? And so you cause enough damage in the upper body, you go eat for 4 hours, you eat in the morning, and you keep eating all day, all night when you get home. Just keep eating, bro. Wake up the next day, do your legs, and repeat the whole cycle. Buffet, eat, this, that. Eat so you're in anabolic growth state, so you're not hungry. If your belly is empty, if you're even hungry, you have hunger pains, your nitrogen balance is dipped, and you're not in an anabolic growth state anymore, and you can't push that domain. That MND size will not reach its maximal threshold where it's going to actually donate any extra nuclei to support further muscle growth. You understand me? Why would it support further muscle growth if it's highly regulated by myostatin, follistatin, and the satellite cell? If the gasoline is not filled in that tank, why would it want to donate any extra more gasoline to support further growth? Why would it want to do that? It won't. Get it? So stop wasting your time like Blaha, lifting a heavy weight. Okay, so you get the picture now, right? So yeah, contribute to hypertrophy, inducing SE proliferation, whatever. By increasing the expression of cell cycle progression, IGF-1 triggers proliferation of myoblasts, which then followed by triggering an expansion of myogenic regulator factors, resulting in differentiated myoblasts through the role of SC activation, muscles and age-related muscle loss. Thus, so it tells you, rescues atrophied muscles in age-related muscle loss, thus further accentuating its role in muscle growth and hypertrophy. There you go. So you get the picture. It tells you right here everything you need to know. All right, this is the conclusion. In conclusion, it seems that the concept of the MND size limit during hypertrophy is conditional and not universal. It's conditional, but not universal. I already know that. As various factors, including satellite cell activation, see, it's dependent on satellite cell activation. It's also dependent on age. It's dependent on fiber type, and I'll bring this up in a second. I told you there's many different fiber types. People don't realize that. The duration and type of hypertrophic stimulus can determine the presence and or extent of the MND ceiling during hypertrophy. So these things are all important. If you don't think they are, then good luck. That's why young people they don't understand that. They're not like older people. Mature, that's why people always say, "Oh, he's got mature muscles. He's got maturity in there. Mature muscles, mature this, that." Well, yeah, I guess you could say that. I don't know about drug addicts on steroids, but natural people and older people, we mature. You look better and more mature when you're 30 as opposed to somebody who's 19, 20, 18 years old. See what I mean? They may be young. They may have high hormones. They may have more hormones. They can get an adaptation in lifting a heavy weight if they keep calibrating their nervous system to do that and proliferating these motor units and these androgen receptors, whatever, trying to lift a heavy weight. But they're not getting bigger in muscular size. They're not getting bigger. See what I mean? They're not getting bigger unless they do specific things like it said there, like I read to you. Okay, so yeah, that's why older people can get much bigger. But anyway, you get the picture. So let me bring up one more type. What they talk about here is fiber type. So they talk about fiber type in here, right? I don't know if I can find it now, but so here's a map. This map right here. It says activation of satellite cells. See, and incorporation of new myonuclei. See that cell way there at the top, the satellite cells? No further expansion of MNDs. There's no further expansion of MNDs. It stops right there after this overload. Okay. Hypertrophy with MND ceiling limit. There you go. Okay. But here on the left side, it says hypertrophy without MND size limit. Further expansion of MNDs without activation of satellite cells. And that's when they're talking about maturity, mature people. You got young people, Mature people. See that? There you go. Anyway, yeah. These are scenarios. They say diagram shows scenarios of muscle hypertrophy with or without myonuclear domain. And you already know, I already explained it to you, it has to do with, it's age related, get it? It's age related and maturity. So, well, here they talk about the type 1s and type 2 fiber types. There are fiber type A and type B as well, and type 2 muscle fibers. I don't know if they come up in here. Maybe it's here, maybe it's not. I don't remember. It could be in another report. But there are different types of fiber types, man. How they act and what they do are totally different. Initial hypertrophy in 3 to 5 days following synergistic ablation occurs without myonuclear accretion, followed by the addition of new myonuclei to support hypertrophy. After 2 weeks of functional overload, the myonuclei content increases by 60%, and satellite cell content increases by 275% compared to sham-controlled muscle. Since 12 to 15 days of synergistic ablation results in even greater hypertrophy, this indicates that prolonged post-operative durations of synergistic ablation lead to an increase in the amount of hypertrophy, more hypertrophy. Yay, okay. So here's some of the types they say, right here. Both types 1 and type A fibers, but decreases in type 2 XB fibers. This is explained by the parallel increase in myonuclei count, fiber size in type 1 and type 2A, but not in type 2XB fibers. These findings differ in different muscles based on the duration of the overload. For example, during the early stages of compensatory hypertrophy, muscle fiber structure abnormalities play a significant role in SC activation. However, in later stages, increased levels of muscle activity lead to satellite cell activation. It will lead to it. It will lead to it. Depends what you're doing. I don't know. So yeah, I'm going to leave it at there. I'm going to leave it at that, dude. So I'll go back here again. This is another one I just posted because somebody was asking me about, remember hydroxybutyrate, HMB? HMB, so hydroxymethylbutyrate, whatever, HMB. They say too, it it enhances the proliferation of satellite cells in fast muscles of aged rats during recovery from disuse and atrophy. So this may be good for old people, I guess too. It's also good for young people. It could help you. I can't say it's a bad thing. Loss of myonuclei could be bad. A loss of myonuclei by apoptosis is thought to contribute to sarcopenia. It does. It's the overuse of it or the loss of it or the non-activation of it. You can lose them. We have previously shown that the leucine metabolite, HMB, suppresses apoptotic signaling, and the apoptotic index, the ratio of apoptotic positive to apoptotic negative myonuclei during muscle disuse and during reloading periods after disuse in aged rats. However, it is not clear if the apoptotic signaling indexes were due to only preservation of nuclei or perhaps the total myogenic pool increased as a result of HMB. Mediated satellite cell proliferation, as it would have also reduced the apoptotic index. Well, yeah, okay. Satellite cell proliferation during muscle recovery growth and the period of disuse, senescent animals and hind leg muscles. Okay, whatever. I'm not going to go into this, man. This is way too long, bro. So yeah, it has to do, they're stem cells. So yeah, it's okay. So functional changes in the sarcopenic muscles, and this could partly explain the reduced apoptotic index by HMB treated muscles. Indeed, muscle mass and fiber cross-sectional area were significantly greater in plantaris muscles from HMB treatment animal muscles after reloading as compared to vehicle-treated animals. Okay, it could help you. I don't know. Enhanced satellite cell proliferation leading to increased differentiation myonuclei should increase the transcription. I don't know. Again, it's complicated science, bro. I'm not really one with what do you call it, supplementation, but I like amino acids are great. I think they're wonderful. So yeah, man, I don't know what else to say there in that video. Tell me what you think about that. Like, subscribe, support the channel. So there are many factors that go into why natural people have so many problems when it comes to, you know, building muscle and a whole bunch of stuff, man. And I'm just telling you right now, if you don't accumulate more myonuclei now when you're young, if you don't force that domain, when you get older, you're just gonna deteriorate and disappear and become sarcopenic. You can become osteosarcopenic like Jason Blaha. Even though he's lifting a heavy weight, he thinks that lifting weights, just doing his little shitty lifts 1 hour every day, is contributing to bone mineral density. Not necessarily. Not necessarily. And he could be using up the stem cells by being in an adapted state, like the satellite cell. You know, understand me? It's being used up. He's not regenerating more of them. So yeah, you may be proliferating them, but they're not differentiating, splitting, dividing, increasing in number, because he doesn't believe in hyperplasia. He's gonna say he got some DOMs or something, but I don't believe it. I don't believe what he says. He's just making up shit, man. He's a lazy guy. He's full of shit. He's the laziest lifter I've ever seen on the entire planet, bro. He'd die if I put him through a weightlifting session like what I do. He would die. He wouldn't make it. He'd be dead. He wouldn't make it. He'd huff and puff and screw off. He has no athletic abilities. That's the problem. I have athletic abilities because I've done a lot of athletic things, and I still do that. I run, I swim, I do everything. I play every kind of sport. I do everything. Rock climb, you name it. So yeah, I think personally you should focus on being, you know, athletic is very important, not just the gym. Gyms are great if you go there to build muscle, but I don't go there for anything else other than building muscle. That's it. I just go to the gyms. I want to build some muscle to get physically stronger and better so I don't wither away as I'm getting older. I'm not interested in lifting the heaviest weight in the gym. You can lift heavy weights if you push that domain and get bigger and stronger. See what I mean? But that's really up to you how big and how strong you want to get. But it doesn't affect you as an older person to regenerate. But yeah. Anyways, I'll see you in the next one, friends. I gotta go, man. Like, subscribe, support the channel, helps with the algorithm. I'll see you in the next one. Ciao, guys. And like I said, if you got any questions, you can write me down below. I'll try to answer them. See you in the next one. Ciao, man.